Okay, review coming momentarily. Factoring with diamonds, because the next thing we're going to be doing right after this test tomorrow is factoring and getting into some of that. We're going to start simple. So if you have done diamonds before, and you probably have in one way or another, you may not have had them called that, but the idea is the same. You start to notice in all of these a pattern of sorts. So you've got these values. Typically, you'll have these two numbers on the side. And what will happen is, if you multiply them together, you'll get the value on the top. 2 times 10 is 20. Negative 3 times 2 is negative 6. 10 times negative 4 is negative 40. Okay? But if you take those same two numbers and add them, you get the number on the bottom. 2 plus 10 is 12. Negative 3 plus 2 is negative 1. 10 plus negative 4 is 6. And that's how factoring in general works. And you may be given different values sometimes. Like for instance here, I was nice on the first couple. I could look at this either way. I could either say 4 times what is 20 or 4 plus what is 9. What would that be? 5. Because 4 plus 5 is 9 and 5 times 4 is 20. Okay? But what I'll get to a point of, because the idea with 5 and 6 are to kind of get you rolling on that front. Once you get up to 7 and 8 and after that, you notice the numbers are in the same places all the time. I'm going to give you that the two numbers multiply to get the number on top, and that they add to get the number on the bottom. So let's see here. Two numbers that multiply to negative 15 but are going to add up to positive 14. Okay, 15 and negative 1. 15 plus negative 1 is 14. Positive times a negative is a negative. And sometimes this may come to a point for some of you, depending on what the numbers are, but again, I tried to keep these easier, that you may literally have to sit and say, okay, here's my number, here's the possibilities, and start playing with the signs until you get something to work. This isn't one of those you can just look and go, well, I tried this one and it didn't work. I don't know. Because that's the stuff that's going to end up kicking you in the tail. Let's find one more here. I want to find something that's a little... Ooh, I heard 10. Okay, let's do these couple. Let's do 8 and 10. All right, multiply to positive 12. Add to negative 7. Now here's one thing I want you to think about before you start throwing numbers out. If this is going to multiply to be a positive, that tells you one of two things. Either both numbers are positive, or both numbers are negative, because negative times negative is positive, but so is positive times positive. So I get my other clue from down here. Well, they got to add up to be a negative. So before I ever start thinking, I know they both have to be negative. That's the problem-solving part I want you to work with. So if I know that, what are my two numbers going to be if I need to multiply to 12 and add to negative 7? Yeah, negative 3 and negative 4. And the order doesn't matter. I can do negative 4 and negative 3. But either way, that's how this is going to work. So you're like, okay, I kind of see this. Now this one's a little more interesting. Multiply to negative 16 and add to 0. Again, I know a couple of things. I know that since they multiply to negative 16, that one of my numbers is going to be negative and one's going to be positive, because I know it's one of each sign with that. And if they're going to add to 0, probably should be the same number. What number times itself is 16? Negative 4 plus 4 is 0. Negative times positive is negative. So we're becoming problem solvers with this. So on the front, I'm messing with these diamonds. On the back, we take it one step further. These are still diamond problems, but they're not set up as a diamond. For instance, I get to this one and I go, okay, so when it says factor, well, what's that mean? Do I have to keep drawing the diamond? No. Once I've got the hang of this, I'm not worried if you don't draw a diamond or not. But again, when I'm doing this, the number on the end is the number I'm multiplying to get. And the number in the middle with my variable, here in this case the 8, is my number that goes in the bottom. That's never going to change. So once I get that set up, I go, okay, so I need two numbers that multiply to 16 but add up to 8. 4 and 4. Now, this time I'm not quite done, because those two numbers, and I know they're both positive, are going to allow me to actually factor this. And here's how factoring works. I'm going to have two sets of parentheses, hence the factoring part. The number is going to be what goes on the end of each one, so the plus 4. And whatever variable I have at the start goes in at the beginning. Because if I were to multiply this out, if I were to FOIL this out, I would get this back. And that's how I can always be sure if I got it right or not. If I can FOIL my answer out and get the original problem back, I'm good. Otherwise, I'm in a little bit of trouble. Same thing, let me find another one. Let's do 19. Again, number on the end goes at the top. That's our multiply number. Number in the middle with our x, or whatever variable it is our add number on the bottom. Think about the clues that you get. Okay? So if I have to multiply to get a positive, it's either two positives or two negatives. Well, I see now it's two negatives. And absolutely, 7 times 2 is 14. Negative times negative is positive. If I owe somebody $7 and I borrow 2 more, now I owe them 9. But again, now I'm ready to use that to put this into factored form. X is my variable. Copy down each of these. And again, the order doesn't matter. If you did x minus 2 and then x minus 7, that's fine. And I'm set. Again, do you have to show me the diamond? No. If you're visual and like seeing what's going on, that's fine. But if you get to a point and you're just like, that's the number I use to multiply, that's the number I'm using, it needs to add, I don't care. I'm fine with that. But again, we're just getting a little math, a little mental math working with you here, so when we start factoring, it's a little bit easier. And then finally, down at the bottom, you're like, oh, what's this? Factor what's in common first, then do diamonds. Because you'll notice it's not just x squared in any of these, there's these numbers. It's because there's a value that I can pull out of there first that divides into all of them. And so basically, to get to here, it's what do I multiply this by to get this back? In other words, just divide it through by 2. 2 times x squared is 2x squared. 2 times 14 is 28. So you're like, oh, so I can kind of just divide by the number on the outside. You could. And then 2 times 24 is 48. But I'm not done, because now what's left in the parentheses, I need to do what I was doing up above. So I'm like, okay, I need to add to get this number in the middle. I need to multiply to get the number on the end. Don't forget the 2's there. That's got to stay in. That doesn't just disappear. So let's think about this for a second.
Wait, can we do the diamonds for that?
Yeah, for this inside part, you absolutely. So like if you were doing this, you could say, okay, so multiply to 24 and add to 14. Yeah, if the visual thing is good for you, I say do it. Okay? And I find out my numbers are positive 2 and positive 12. And so I just put a positive 2 and a positive 12 in here. And I'm set. And just like I said on the others, if I wanted to make sure that I was right, what I could do quickly, if I were to FOIL this, And we'll talk more about some other ways to do foiling stuff as we get into this more. You're like, why aren't you doing the 2 yet? I'll show you. So I've got first would be x squared. My outer is 12x. My inner is 2x. And my last 2 times 12 is 24. And again, little smiley face guy shows up when we do it right. So x squared plus 14x plus 24, just like I got when I did this. And then I distribute my 2 through. And if I multiply to those terms, I get the original problem back. Do I have to do that every time? No. If I'm not sure of one of my answers, might this be an idea to make sure it's right? Sure. Okay. But on 25 through 32, you have to take that first number out first, factor it out, then do the diamond on what's left. If you're visual, do the diamond. If not, just put the add and multiply parts at the top and do it. Okay? Like I said, this will be something we'll be starting up on Wednesday because tomorrow we've got the test course. Any diamond factoring questions before we go a reviewing here? Yes, ma'am. Sure. Let's see. Okay. Let's do 28 because we'll get some more room down here. All right. So each of these I notice, and typically with these it'll be the first number. If I take a 5 out, again, it's basically I'm saying 5 times what gets me the first term, x squared. 5 times what gets me 10x. 2x. And then 5 times what gets me 175. If you're not sure, just do 175 divided by 5, which is 35. And then what you're doing is you're doing the diamond on the part that's left. The number on the end is what we're trying to multiply to get. And the value in the middle, minus the x, of course, is what we're trying to get to add to that. So multiply to negative 35, add to 2. But again, I've got some clues here. What clues? Well, if I multiply to get a negative, I know one number has to be negative and one number has to be positive, just because that's how multiplying with positives and negatives works. And the other thing I know is that the positive number has to be bigger because my sum's going to be positive. Again, that's the thought process we're trying to work. So think about what are some pairs of numbers that multiply to 35? 7 and 5. So which one's which? Positive 7 and negative 5. Leave my 5. Now my parentheses become 2 sets. My variable is x, so I put that first. And then I just copy my 2 values, my negative 5 and my positive 7 in either order. And I'm off and running. So that's kind of our deal with those. Okay. All right, let me move this to the side. Now comes the other portion of our day, firing away questions from the test preview. Any particular problem to start? We can bounce back and forth. Yes, ma'am. Number 8. All right, let me move this up a bit. Now this goes back to our famous, wait a minute, I'm trying to solve for a variable, but I see 2 of them. Typically what that means is I'm going to have to factor it out because then I can get down to 1 that way. So these terms both have an r. So I'm going to take the r out. And I know it's kind of strange with the r being in the middle, but that's okay. So what do I need to go from r to 3rx? What's missing? 3x. And then this is the place I got to be careful. R to get r back. Plus 1. Because 1 times r is r. And all of a sudden, I'm down to just 1r, which is good. Because now, since I'm trying to solve for r, I'll just divide by all that other stuff. Since I'm multiplying by it here, and that'll wipe all of that out. And I'm good.
Can we do 7?
Sure.
And 6.
Okay? Again, the biggest thing on any of these, when we're doing the equation stuff, is kind of looking at these like you'd look at a regular equation. You're like, okay, if I'm trying to solve for t in this case, if we move our way back across here, my first job is I've got to get that portion of the fraction isolated, because then I can start working towards getting t alone. So since I'm dividing by 3y in this case, I'm going to multiply by 3y. Now again, and I'm going to keep saying this, that 3y's whole job is just to cancel out the denominator. Do not distribute the 3y on the right side. It doesn't work. Because once you get here, it shouldn't be too bad, because now it becomes, okay, I want to work on getting this 2t by itself. Well, I'm adding a to it. Okay, I got to get that out of there. And again, don't lose pieces. 3yx minus a equals 2t. And since I'm trying to solve for t at this point, I'm just going to divide by 2, and all this stuff ends up being my t.
I have a question.
Sure.
I put x times 3y minus a divided by 2. Does that make sense?
X times 3y minus a divided by 2. Yep, same thing.
Okay.
And then 6, probably what might be getting you is that whole r squared thing. Because if I'm trying to get r solved for, okay, I'm multiplying it by pi. Undo that by dividing. You're like, okay. Here's the part that some of you look at and you go, do I divide by 2? No. The opposite of squaring something
Square root.
is to square root it, because the squared and the square root are inverses. They're opposites. And then I just got to keep my square root on the other side, and I'm good. What else sounds interesting? Yes, ma'am. 15. Up to the middle we go. All right, step functions. Now remember, step functions we're going to deal with like they're just graphing a regular line. So in other words, with this, I'm going to read it sort of like I would y equals negative 2x. Well, if that was the case, my y-intercept would be at 0, and I'm going to put filled in dots on all of these initial points that I make. And my slope from here would be negative 2 over 1. So I go down 2 and right 1, down 2 and right 1. And if I run out of room, again, I can do a double opposite. So instead of going down and right, I can go up 2 and left 1. And get myself these dots. You're like, okay, well, that's the line, but what's that do to help me? Step functions, remember, are just a way for you to work from left to right to keep showing the values. So here, I make my bar as long as where the next point starts, where my next filled in dot is. So I do that here. Okay, there's the step. There's the step. So you notice as you move from left to right, okay, I go here, oops, open circle, oop, but there's a closed one right below it. Open, closed one right below it. There aren't any gaps in my values, but that's how the step function will work. And 16 would work the same way. I'd graph it just like I was graphing the line y equals x plus 3. I'd put a dot at 3 on my y-intercept, and it's just up 1 and over 1, up 1 and over 1. and keep making my little bars, my little dumbbells, so I don't see any gaps as I'm working through there with my steps. Keep on firing. Because I want to make this test put all your grades on easy street here. Any other issues that you see? What's that? Okay. So here when we're evaluating, okay, here's my key on these. My first step is always to look at the inequalities, figure out which one it is, and then I figure out where it gets plugged in after that. So here's how this goes. All right, I'm going to pay no attention to those expressions here at the start. So f of 1 tells me that my x value is 1. Which one, the top or bottom, does that fit into? The bottom one. So once I see, okay, it fits in the bottom one, now I can come to here and I say, okay, now I plug this value in that expression for the bottom one. So since it's negative 2x plus 5, I plug in the 1 for x. And negative 2 plus 5 gets me to 3. And that's the same process I'm going to run through on every one of these. I'm like, okay, negative 6 fits into the top one for 18, because negative 6 is less than 1. I'm like, okay, so we're the top one. Whoops, covering up part of the expression. So 1/3 of negative 6 minus 3. And again, if fractions are your downfall, a little side work might not be a bad idea here. So 1/3, I'm going to turn my negative 6 into a fraction, if that's an issue for me. Multiply across and reduce my fraction. Okay, so this is really negative 2 minus 3, which is negative 5, and I've got my answer. But that's how all of these work. It's always which one does it fit into first, and once I figure out which one of those is true, I can determine which expression I'm using. It's never for both. It's only going to be for one each time. And that's the big thing with those. Anywhere else?
Number 20 and 21. That's the only thing I have.
All right, little piecework. So let's see here. Okay, when we're doing piecewise, we're going to do one part at a time. And since you asked, you get to pick. Are you a tabler or an eraser? You're an eraser. Okay. So what we're going to do here is we are going to graph this line, 3x plus 1, and then we're going to figure out where we're starting. So, okay. So 3x plus 1, make a dot here at 1, and then my slope is up 3 and right 1. So up 3 and right 1, 3 and right 1, right 1. And just because I want to be sure I got everything covered, I want to get my dots everywhere. So we're going to go down 3 and left 1, because we got to stay on the same line. Down 3 and left 1. Okay, so I'm fully dotted. So now I come back and I go, okay, if x is less than or equal to negative 2, okay, here are my x values along here. So I go to where x is negative 2, and now I see where that matches up on my graph. So right here. So I get here and I say, okay, I got two questions I got to ask myself. One, is my dot going to be open or closed? In this case, it's going to be closed because I have the or equal to. So big old closed dot here.
Like, I get how to do that. I just don't know which way the line goes.
Okay, so here, okay, and it's good because we actually got the number line numbered. x is less than or equal to negative 2. In which direction are my x values becoming less in value? To the left. So I want to find all the dots that are to the left of my colored in dot, which is just this one, and connect them.
Why isn't it marked at -2 since it says x plus because you do the points and then you find it.
Right. Because if you're it depends on if you do it by chart or if you do it by graphing the line and then going back and erasing. If you are an eraser, I'd want to go this route, and then but again, here's the key. Your graph has to start at this value for both. If it comes to the test tomorrow and you start at the y-intercept or some other place, I'm not even going to try and figure it out. It's just going to be wrong. Because that's the biggest part with these. Second one, same thing. Graph it just like you would a regular line. There's my y-intercept. Only put the negative on one of the two numbers, so I'm going to put it up here. So down 1 and right 2. Down 1 and right 2. Down 1 and right 2. And I notice, I'm like, okay, I got to keep going because, again, it starts at negative 2. Up 1, left 2. And I'm just dotting out. Okay, that'll be enough for me. And then the two-part question starts again. Okay, here's my x. I want to be at negative 2. Ooh, right there.
So it's an open dot?
It's an open dot because we have no or equal to. And since x is greater than negative 2, you go to the right because my values are getting greater as I go to the right. So I connect the dots with the ones that are heading to the right. I conveniently erase the other ones, and I'm done. But again, my lines have to start where the restriction tells me I do not get to pick. Under any circumstances, I do not get to pick. Now again, if some of you are charters on these, because some of you may say, you know, my biggest strength isn't necessarily, doing all of this stuff and then erasing. I'd rather just do a chart. Okay, if you're doing that same problem and you're doing a chart, clear this out here. I would just type the expressions in one at a time in here and use second graph to get the chart. But again, I'm starting at negative 2. I know that. And I also have to know which way I'm going to be looking, left or less values. So if I were doing a chart for this one, I'd be doing an XY chart. I'd be starting at negative 2, but as I go left, the numbers are getting less. So like negative 3 and negative 4. So let me get those up. I'd copy those numbers down from the chart, and then I'd go left 2, down 5, closed in dot. Left 3, down 8. Notice it's the same dots. Put it in. Left 4, down 11, a little further than my graph goes, and connect the dots. So you don't even have to be a graphing lines expert, even though you do really need to know how to graph a line. But that can be your backup plan. And it's the same thing with this one. If I don't want to have to worry about what I'm erasing and what direction I'm going, no biggie. Negative 1/2 x minus 1. And I do have to put the negative 1/2 in parentheses. But again, this one's going to the right. I'm still starting at negative 2. But as I go to the right, it's negative 1, 0. And I could do a couple more if I wanted to. So I'd be at negative 2, 0, negative 1, negative 1/2, and 0, negative 1. Negative 2, 0, open, okay. Negative 1, negative 1/2, 0, negative 1. Connect the dots. Okay? They both work. They both work equally as well, but you've got to know which one you want to play with. So it's the same thing working on 21. I just want to do it to really stress this and punch it home here one more time. When you're graphing these, even though that's probably going to be enough, you've got to pay attention to the if part, because that tells me where x is 3, right here, there's my graph. Open circle, because again, it's not or equal to, and less than means I'm going left. Connect dots to the left. Erase dots to right. And I'm going to keep playing that way for both of these. So negative 2x plus 3 down to 1, down 2 and right. And right 1, down 2 and right, down 2 and right. Okay. Get yourself lots of dots. Or do your chart to figure out what values you want. Because here I'd used 3, 2, and 1 because my values were getting less if I was a charter. Here I'd use 3, 4, and 5 because greater means I'm going to the right. But again, I'm starting at 3. Nowhere else. 3 to the right. Erase. Happy. But you will, on all these piecewises, those first 2 dots, the first one on each of your lines, they have to line up. There cannot be a gap. And this is something that I take very seriously at the bottom as well, okay? Once you've gone through this, even after today, maybe it's just a couple of things and going through a couple of them fixed you on it. That's great if it did. But if you're still having issues, okay, this is good advice. Because most of the problems I give you are evens. So if you're still having trouble with something, because you'll notice each of the sections tell you what section they're in, go back, do some of the odds, because then the answers are in the back of the book, and you can make sure you're doing them right. And then if something's still going haywire, you call up somebody if you have to, set the alarm clock 15 minutes early, and you come and see me in the morning to make sure things are going okay. Or maybe rewatch some of this later. But again, that's not something I'm going to see since I don't get the reviews. The reviews are on you. If what you put into them is what you're going to get out. So hopefully, though, it gets you good and ready for tomorrow. I hope. I really, really do. Any other issues? Issues. Because I'm going to say it one more time. Just because I don't want to say it for a third time in a video somewhere. Okay. When you're working on these others, like number 5 or number 11 on the front, isolate your fraction or your absolute value first. I do not want to write on any more tests or quizzes -8 both. Oh.
Good interruption. Is Allie Bond in class?
Yes.
Will you order from the student services to me, please?
Okay.
Thanks.
Isolate your fraction, then deal with it. Or if it's absolute value, isolate your absolute value before you split it. Okay? If it's absolute value, you even get a hint, both solutions, there's 2 parts. Once it's isolated, you can split it, only changing the answer. And get 2 answers, and woo, we're happy. So please do it in things that are sensible. Sensible. Okay? For most of you, like when you're doing number 1, I still have some of you that are like dividing by 2/3, and you don't even understand what that means. Because you'll divide by 2/3 and you'll tell me the answer is smaller than 18, to which I go, deal with it where we can understand what's going on. Do not make the calculator be your brain, because that's trouble if it is. Otherwise, end of mini lecture on the end. Hopefully it sticks. Hopefully I didn't scare it right out of your brain. We'll see. Any other issues?